Hey there, how y'all doing? I wanted to spend just a few minutes talking a little bit about chapter two. It There's a lot of PowerPoints that go with that, and I'm in the process of kind of culling out some of the PowerPoint slides that may not be quite as relevant. I've noticed that some of them are out of order. These, of course, came from the manufacturer or the publisher, and so, but I'm working on that and intend to do some more narrated PowerPoints. This chapter gets into the kind of the basics of research. Some of you may have had a research course before. You may have taken statistics before. A lot of this revolves around about program evaluation. So a lot of the terminology is the same, but I wanted just to kind of hit some of the highlights a little bit. I don't want to go back and like beat the dead horse, but I want to help us to focus a little bit. Of course, when we're talking about research, in the social sciences area or in government, if you will, it's the purpose is a whole lot different. A lot of time, math and science. Why is the world round? Um, Not sure we really care. I don't anyway. But in our purpose for doing the research, there's a reason for our research. We want to make a change. We want to make it better. We want to increase something, whether it's satisfaction or decrease something, such as firefighter deaths and injuries, or um, prove that something's working or prove that something's not working and how we could do it better. So it really does come down to evaluation in a sense when we're talking about doing social science research or government research. In our process, we really don't, and I'm looking over here at my book, we really don't form a hypothesis. Maybe, but not really. Our research is more in the form of questions. And that's why when we're looking at your research proposal, you've got a problem statement, you've got a purpose statement, and then some research questions that we're going to look at to try to, and that's what you conduct your research on, are those questions. So while we need to understand what a hypothesis is, it's not something that we're actually going to be formulating. Now, in many ways, we can, as a part of our purpose, is a form of a hypothesis. If we want to show that um, washing gear, firefighter turnout gear, on a regular basis decreases the chance or the risk of cancer. That's kind of a long term project, but it would be our hypothesis that um, this is it's a positive thing that yes, it would decrease it. So that's our hypothesis. So in a sense, we are formulating a hypothesis, but it's not as scientific as it might sound. And so I don't want you to get bogged down in that. But remember, we pose questions to focus the research, and that's the most important thing. When we look at the purpose of this research is to show X, that washing of turnout gear decreases the chance of cancer. And then we would have questions about that. How often do firefighters wash their turnout gear? What is the risk of cancer for firefighters? And again, this is a big time study, and you'll find one of those studies. Actually, NIOSH did a study on cancer and firefighters that you may want to look at and look at some of their parameters. That might give you. I will post the link to that on the course site under your resources section. Um, but the hypothesis, the theories, the questions guiding the research. I wrote 4 research projects, or not proposals, but actually did the research for my EFO. And when I would get bogged down, when I would just be like chasing rabbits over here, um, I would get out my research questions and I would really focus on them. And I think that's why they're so important, is that what we do in focusing on the front end, as far as the purpose, the problem, the purpose, and the research questions, keeps our minds focused, keeps our research focused, keeps our data focused, keeps our literature review focused on the problem that we are looking at. And so you don't go chasing rabbits. That is why I'm really focusing on those a lot. I want you to get those early on, and so that we can look at those and talk about those if we need to, and refocus them or redefine them a little bit. But the variables, that this unit talks about the variables, observable characteristics of a concept, the values, and even the levels of measurement. We've heard those terms, nominal, ordinal, interval, and ratio. You may not be getting into a lot of that in your research, but we do need to understand, so when we read a report, such as something that NIOSH does, um, that we can understand what those things are. Nominal data is just a category, male, female, um, religious belief or religious affiliation, you know. And then ordinal is a name, but it's got an order to it. Your highest level reached in your highest educational level level reached is considered ordinal data. There's also interval data, um, and then these are real numbers, but they don't really contain a 0 point. And then your ratio data has a 0 point. These are real numbers, such as income, 0 to infinity, I guess. And then the causality, this is where our variables come in, our independent and dependent, because we want to determine a causal relationship. Take, for example, our cancer and firefighter gear. We want to show that turnout gear that's not washed, or that carcinogens on turnout gear can be absorbed through the skin and cause cancer. That's kind of what we're looking at there. So on page 22 in your book, there are 4 standards that must be met um, to demonstrate that a causal relationship exists. There has to be logical theory connecting the variables. And to me, that's very logical. There has to be appropriate time, order. The causal variable has to come first, dirty turnout gear, um, before the cancer. There has to be covariation, meaning both variables have to change. So that means that the dirty turnout gear and the cancer, and then all other possible explanations for the observed changes are ruled out. And we know that this is true when we talk about doing fire investigations. We have to rule everything else out, and then when all that's left, we know it's arson. So it's kind of that scientific method that we have learned a lot about. The book goes on to talk about independent and dependent variables, control variables. You may have I'm trying to think just of examples in our turnout gear and cancer. You may have somebody that has clean gear, brand new gear, let's say, and they always wash it, and maybe that's your control group. Or in maybe a better scenario is the guys that never wash their gear. They don't wash their gear, and of course that I don't really like that because that might cause harm. But you get what I'm saying. You have to have some there's a control. Um, a good example would be when I was doing fire and life safety education. I did some research about the value of that in, say, the preschool, pre-K environment. And so you administered it over here. You administered a pre-test and post-test to both groups. And then in the control group, they got no education. They just got the regular dog and pony show, as I called it. And then this other group got monthly fire and life safety lessons conducted by the fire department on a regular basis. And then you compare those scores at the end of the year. So that's your control. We know what a control is. What I really want to kind of point out, and you'll see that I posted a discussion question, I'm sorry it was a little bit late, about logic models. I like logic models because they're logical and useful for us. A logic model is just a way to measure results. And, it's really hard. I began to learn about logic models when I did fire and life safety education, simply because it's hard to measure what you have prevented. And so it's really hard to document your work. What do I do every day? I have many times I had guys saying, "Oh, it's the summertime, you don't have anything to do." And so what the logic model to me is another way of evaluating people, but you can evaluate programs, you can evaluate your research because it's based on outputs and outcomes. And thinking about the inputs, the staff money, office space, whatever. Think about your fire marshal's office. You've got staff, you've got a budget, you've got office space. Those are your inputs. The activities are these investigation or inspections that you are doing, let's say. So the outputs, the number of inspections, the number of violations found, the number of violations corrected. Um, and so then your outcomes are going to be how how that changes, how you can increase that, how you can change that. And then the long-term impact is, of course, did it do any, you have to formulate again that hypothesis that by doing inspections, we have reduced the effects of fire on in businesses, or we've reduced the number of fires in businesses. It's a little more, of course, complicated and calculated than that. But the whole logic model is, to me, a great way to look at our research, to apply it because it's not scientific in a lot of ways. And we'll learn about data. I think we read about some, qualitative and quantitative and anecdotal data and the importance of that when we're taught, even when we compare that to our quantitative data. So I want you to really kind of look at the logic model. I don't want you to get hung up in all of these terms, but it is important. I'm probably going to put some kind of quiz up there that whether it's a matching or a multiple choice or something about the terms that are identified in the different chapters, because I really think that it is important. I was teaching a class the other day I was actually in Seattle teaching a class to a bunch of campus safety folks. And there was one guy there that was like, he was Mr. Brilliant. And I was talking about going by the curriculum and talking about research that had been done. And he was saying, is there information that shows that, that these programs are making a difference? And I said, well, I don't have it here, but I'm sure you can look it up. And then he said something about, well, if they came out with a null hypothesis, then we don't want to do that. And I kind of knew what he was talking about. I had an idea of what he was talking about. I knew what he meant. And so that is another reason why I think this is important is we need to understand what these terms mean. We need to speak intelligently about it. But also when we are doing research, I think it's very important. If you are having problems with either the terms or the concepts, if you go to the National Fire Academy FEMA nfa.fema.gov and look for the library, the Learning Resource Center. And you can search just for EFO papers. You don't have to have a topic. You don't have to have, just you can, there's a checkbox for EFO papers. Click on those, and most of them are online now, and you can download those and just all you have to do is read the first 3 or 4 pages. Their abstract is there, then it's going to give you the problem statement or the purpose, the problem, and their research questions at the very beginning. And then they go into their literature review. So take a few minutes and look at those, and that will kind of give you a chance to check that out. So look at the video on logic models, and then I've given you some ideas about the discussion, but I want you to discuss, in that discussion question, I want you to discuss how you can best use logic models in the research that you are thinking about doing. And let's kind of get the hang of what a logic model is, how we can use it, and how they're beneficial to us in public safety. So let me know if you have any questions, comments, concerns. Thanks so much. I appreciate it.